on the darknet markets. And when we ran Hansa, and then it's so dangerous, you could really quite easily die. We said like, okay, we can't just
How did you guess?
Test.
we changed the rules of Hansa, and
Met de vel daar klaar is, dan ook de camera kaart
we actually did that because we can't explain that later.
And there's also the irony that you were saying yourself.
They had a great confidence in
And the other sites in terms of diplomacy. And so the irony is that you were with a more ethical site than you would have been if you didn't have any qualms whatsoever.
It would be sites that allow assassins, guns, and that's where we would have a real problem getting that jurisdiction done.
What I think the rest of the world can really see in the way the American police operate is that there's an argument to be made that the government itself, ironically what you did, would be, these sites would be in better hands with a state option that says that this is more of a libertarian perspective. But it's basically saying, if you're going to do it, you pay taxes and you can seek help any time you want. Or you have to come to a facility. The thing is, this is the line that people aren't prepared to cross when it talks about what is the boundary that you can pursue when it comes to making these kinds of arrests. And this is far above your pay grade and probably the pay grade of anybody in this country because this is political.
Yes, this is a completely different
And yet this is a problem in the States because the police hold such lobbying and sway over politicians that in fact they prefer a more enforcement and punitive approach than one that actually might be better for society in the
It's like an extension of the legalized drugs, so it's better for state control.
Yeah. And I feel so confident talking about this because even after moving to the Netherlands, I've never taken drugs and I don't believe in taking them. It's very easy for me to take the position of a contrarian indicator that says the legalized drugs that America sells, the Oxycontin and all the things that we subscribe to, are part of our opium epidemic much more than the illegal drug market. And and I think Holland has a better approach to it than most of these other countries.
I guess that as much data as we have on Hansa, it has little use to go after every seller,
Exactly.
So we're really aiming at the top sellers and the top buyers, and for the top buyers, we did lots of conversations where we just go to every door.
It's very interesting. So
Showing niks. Hier kan zijn kabel of zo. Ik zie nog geen beeld. Hij laat geen beeld zien. Ik zie wel een monitor, maar...
Welk kastje moet hij doen?
HDMI heb ik geprobeerd en een VGA.
Van deze...
Deze even power cycle wil ons helpen.
Try to plug it in and plug it out.
Dat hielp vorige keer in ieder geval.
You can say that when the bomb squad is busy.
Just a second. Jouw beeld op het scherm? Nee. Dan heb je nog geen... Oh, daar komt het. Ja.
Gaat wat komen, het kastje is...
See it here, it should be over there.
Ja. Okay, let's give it up for Bart with his talk about beer brewing using a Ultratronics controller.
Thank you.
The talk will be recorded.
Welcome, alcoholic hackers. Welcome to my presentation. I'm Bart Meijer. I'm the owner of Reprobuild, 3D printing company. We are with 3D printers. But as a hobby, I have a home beer brewing. So I've been doing this for about 3 years. And today I'm going to explain to you how I have automated my beer brewing system. Let's see the topics. For the people who are not familiar with beer or how it's made, I have a small introduction on how to brew beer, and just the basics, so you can follow the rest of my talk. I'm going to tell you something about how I did it in the past. I'm going to explain what a HUMS installation is, and my attempt at building one, and things I have to improve and do to get further with my installation in the future. So to start with how to brew beer, the most important part is the mashing. That's where we are able to make the sugars free in the malt. That's what we do with around 65 to 78 degrees Celsius. It has to be controlled a bit, so you cannot go exceed above the 80 degrees, because then it becomes not toxic, but the taste is going to be very bad, and the sugar process stops, so the fermentation will not be able to proceed with that batch anymore then. So that's something you have to be careful of. That's the mashing phase. It takes about 1.5 to 2 hours, depending on your recipe. The next stage is the boiling. That's where we have the wort filtered. We put it in another pan, and we boil that with 100 degrees, of course. And we add ingredients like the hops, sugar. If you make special beer, you can add herbs or anything you can do with beer. That's the phase to do that, probably. And finally, we have the fermentation part of the process, which is where we actually make the alcohol in the beer. And that's the yeast doing. For now, we're going to focus on the first two, because that's the brewing part of the home brewery. So please try this at home. It's very fun, and it's not that hard. Actually, if you can cook an egg, you should be able to do this. My previous process was this. The first step is the mashing, as I told you. That happened in a large aluminum pan on a gas flame. Gas is very hard to control, so you have to manual pitch tune the temperature. So you're going to more bang style. You go up 5 degrees too high, and you let it cool down 5 degrees too low. So you have 10 degrees variation in temperature continuously. After the mashing is done, you put it through a filter. That's why you have the fine stuff filtered out. I put it in a basket, so it was like hot stuff going to tubes in a basket. Throw that back into the boiling pan and start the boiling process. Finally, we go to the fermentation process, which is out of scope here. This all happened in a small room. When we started building our new house, my boyfriend was kind enough to give me a room for my own brewery. And I decided I wanted to have a HUMS installation. HUMS stands for Heat Exchange Recirculating Mesh System, which means effectively you're going to push wort through a heat exchanger and to keep it at temperature. Sounds easy? This is the result. No, this is a professional one, probably around 10,000 euros or so. You can have them in a few variations depending on what you want, but something like this it could look like. Why do I want a Hermes installation? The temperature control is better, as I said, because you have a large tank with water, and you can keep that up much better at temperature, and by putting the wort through there, you can very precisely control the temperature. I measured around 0.5 degrees variations by using this system. Another benefit is that you can pump the wort instead of hosing it with baskets, which is reducing the evil of the brewing process, which is oxidation of your beer, rust. It starts to taste coppery when it's oxidated. So that's why we want to avoid throwing around with the wort too much. And another great feature is that it has continuous filtering. I'll come back to that in a moment. And because everything is semi-automated, it's much more controlled. So I have much more control over the end result, which makes it easier to affect the recipes or change the recipes and see what's happening at the end result without the variations you get between different batches too much.
Simple question. The heating is still done by propane line, or you must have electricity?
I'll come back to that in a moment, 1 second. And this is my design. You can have with multiple pumps, more pumps than this. I decided for the more economical way, using gravity to fill up the boiling pan. So the pan on top is the wort pan. That's why it's yellow. The pan on the bottom is the heat exchanger. It is blue. I'm not sure if it's on the screen blue as well. The wort is guided through the pipes through the heat exchanger into a pump, and the pump pumps it back into the wort pan. For the heat exchanger, there's water in there, around 40 liters maybe, and that's continuously pumped around, so it has as much equal temperature as possible, consistent temperature. So the whole process is using 2 pumps, a few valves, which I have to open or close manually, depending on if I want to pump the wort through the heat exchanger or I want to finalize the process by putting it in the boiling pan. At this point, I only have the mashing phase automated. What I wanted to achieve with this system is, of course, I want to brew beer, and I want to do it in smaller batches, because I had a big mashing pan. It has a lot of water in there. Otherwise, if you have a large gas pit under it, it's even harder to control the temperature. So always needs to make at least 20 liters of beer, which is fine. But if you want to test out a bit, it's a lot of drinking to keep up with that. And another benefit is that I can do multiple batches on a day. Where I had to do 6 hours of brewing before I had my batch ready, I can now continue with another batch while the first batch is still in the boiling pan. So it's much more efficient in time as well. Also, I decided to use Python for the software to control the whole thing, which is something I'm not very good at yet. So I thought that was a good exercise. I had to learn how to make an electricity group in my fuse box. And I wanted to weld the frame myself, but people who loved me really advised against doing that. So I scratched that part. No, you shouldn't. You shouldn't do that.
Get the experience first.
Exactly. Electrically, it looks like this. This is a 3D printer controller board, which normally we use in the more higher end printers. But I have a few returns because there was a problem with it, so it's an easy, cheap solution for me. It controls 4 solid-state relays, 2 of which are used to heat up the heat exchanger. So it's electrical, to answer your question. Another 2 are controlled using to control the pumps. One is the pump that does the wort pumping. Another one is the heat exchanger. As feedback, I have 2 thermocouples which tell me with the actual temperature of both the tanks. I had to write firmware to make this, and it's Arduino based. So I used 3D printer software. I uploaded that, and I hacked a few things. So I thought it was extruding filament instead of wort. Doesn't really matter. What do you need to build such a device? I bought 2 quite sturdy tables from the internet. At the Hornbach I found copper already in shape that exactly fitted in my meshing pan. Some high quality water cookers from our second favorite plastic the supplier, Action. And it kind of looks like this. I will come back to the result later on. This is the filter. So when the wort is being pumped around, it is continuously going through a filter, and it gets better over time because the small particles stay on the top, on the bigger. So you're building up your own draft as a much better filter during the process. I had to have 2 stainless steel pans, 2 pumps, my own board. If you have a broken one, it's cheaper. The 4 solid-state relays, some pipes, bolts, valves from the local Hornbach. So the result, I got the frames attached with some screwing without welding. The aluminum pan, I drilled out the holes and put in the heater elements from the water cooker. It's quite a waste because all the parts from the water cooker I had to e-waste, but it was the cheapest solution. I drilled holes for the pipes, so the pan can be attached to the 2 flexible the pipes. On the left is the system with the water on top. The heat, the wort pan is on top, like you saw in the other picture, and I'm filling up the heat exchanger with water apparently. And the thing on the right is where I can cook with the gas on the bottom. The heat exchanger is the spiral where the wort is coming in. It's going through a lot of water to heat up, and the pumps are doing the hard work continuously. This is the electronics from the bottom of the plate. I have one fuse, a 60 amp fuse on the left, so I can turn off the whole system immediately. You see the board attached to the solid state relays and the power supply for the electronics. On the right is the shower head I bought to. Well, the problem that I had is that when you pump in the wort, it's like one big waterfall kind of thing, which gets up the draft again. So I had to reduce the force of the water coming into the wort again, and by using a standard shower head. I get to the software part. Like I said, this is written in Python. I can show you to you right here. On the background, I have to do it on the window. is closed. On the background, I have a little piece of software written that will accept commands and act like the heat exchanger.
Simulation mode.
For debugging purposes. I don't want to debug while I'm actually cooking. That's not. I've written everything using Eclipse as IDE. This doesn't look good. This does look good. This is not an error. So this is the program. I have the heat exchanger at temperature. I have the meshing pen at temperature. I have a graph showing both pans and on temperature. I have a timer. Like I said, you have certain phases, and the meshing procedure is, for example, 10 minutes at 60 degrees, a half an hour on 65 degrees. So you have a few steps you can take during the meshing, and that's the part that's automated. So I can control by hand. I can set the temperature for both pans manually. I can turn on the motor. The meshing doesn't need the motor switch because the temperature is regulated by turning on or off the motor on or off. By pressing Start Program, it asks me if I want to run the program. Yes, I want that. And it's going to set the temperature to a few degrees in a moment. And it's starting the timer. I hope. Oh, no. So the red means it's heating up, or the heater is on, actually. And it asks me to add the first ingredients, being the malt in this case, because it decided the pan is on temperature, so you need to add the malt, and we go to the next step. So we'll go through the whole program automatically. After it's done, in about an 1.5 hours, it will stop automatically, and I have to do manually the rest of the procedure. In building this, I made the Python program, of course, and I made it that I can make programs. For example, I have andor.ale.xml, good old XML, and I made a definition where can I define the phases. So I can manually add or set all the variables for my program and run it. I need to make a GUI for this, but who needs a GUI?
Can you select multiple recipes, for example?
You cannot do that right now yet, but I want to do that, of course. So I can easily change to a different program. For example, I have a few recipes I like to make. I want to be able to load them, and also I want to put in feedback. So what I think exactly, but it's something I have to still work on. After I get to a certain point, I'm going to put everything on GitHub, so people who are interested can use it and share the rest as well. Upgrades I like to make in the future. I want to have the boiling phase automated as well. But before I can do that, I also need to implement automatic valves somehow, electrical valves, so the system can control that as well. I like to improve the cleaning procedure because after you're done, you need to clean all the pipes using a lot of water, and I'd like to be able to do that better by maybe adding more valves, or I have to think about it. Like I said, I want to have a 100% automated system, so I could find maybe a way to automatically insert hubs or something at certain points, and maybe some safety procedures or alarms or anything that may help as well. Well, you have a question?
So you were talking about the fancy.
Box.
You were mentioning the fancy 10,000 euro plus system, you know, that is that also, are those type of systems automated and they have all the other future upgrades that you want to do?
Yeah.
Okay.
Those are generally fully automated. Well, there's of course the cleaning you have to do yourself, but in principle you can fully automate the whole process.
Is that something that's available for public knowledge, or are you going to have to learn how to implement many of these things yourself?
The principle isn't that hard to understand. There are some complexities on the materials you're going to use, so that's why a professional machine comes in. But in general, it's not really a hard process to understand or to find the equipment to make it. Any other questions? Anyone wants to try a beer? Oh, I have some lessons over here. If anyone who likes to have a sip, you can come up over here. It's an imperial stout, so you have to like real beer.
For me, only a small bit, please, because I still have to drive.
It's not.
But I'm going to taste it.
It's about 6.5% probably. So.
Yeah, that's why I said that. Yes. Thank you. Thank you.
Welcome. Sure. Tastes like beer? Thank you. Okay. Those are not my labels, so we're not that. No. You want those? You want some?
No, still practicing last night.
Is it your same hobby stuff?
Yeah, you don't like it. If you like it, I also serve beer at our beer pizza party at Rubwood in Nuremberg. So that's a one place where you can find it. I'm maybe looking at a local pub where my uncle is managing to have it on the list. I cannot sell it because you have to pay taxes on that, and I don't want to get into that mess.